the offset idea for bars. Did we get to talk about it at all, Kim, or no? Did we start?
Yeah, we started.
Okay, so did we? One, come on. You've lost your seat. Thanks for teaching us how to turn on the graphing calculator. Okay, so how are you gonna?
Yeah.
I'm cool with that, but I don't know how you're gonna do anything.
You can figure out the calculator.
If he can figure out the calculator, he can find it. All right. So, what is the data over there all about? If you're good, I have dessert today. Some of it's really good too. Name? What was the what is the data in the question example all about? Come on, let's get through this stuff. Name? Paulina? It's about temperatures. Can you be more specific?
There list the daily temperatures in July.
Yes.
The city in South.
You go to
There we go.
Good. What, Nicole? You like dessert, obviously, because you're never involved. Yeah. What's up?
It's the daily high temperatures in July.
Holy! So that's all it takes, eh, Nicole? Dessert, and you're in there. Okay. Don't worry. It's going to be an aggregate of good vibes from who I decide to give dessert to. Yeah.
This is a collection of raw.
Oh man, come on, dude. Yeah, we're done. We got it. Okay. It's daily temperatures, and it's the day of the month, and the bloody temperature. I was about to swear there. That would have been an edit, by the way. Is the thing on, Orange?
Yeah.
Okay, so that would be an edit. That would be an edit. All right. So what are they asking you? What are they asking you to do?
They want us to group the data and create bar graphs and frequency.
Right. They want you to group the data, create bar graphs and frequency tables. Okay. For bar graphs, something that you're going to remember that's important is we're going to make the widths of each bar identical. So now. The thing is, there's nothing set in stone as far as how wide the actual bars have to be, right? I mean, the wider the bars, the less bars you'll see, right? I could take the lowest data point, the lowest temperature and the highest data point and say, that's my interval width. And what does your bar graph look like? There it is, right? So, having said that, you might get a question on a test or on a quiz, which is like similar in terms of asking you to, I have those same shoes, those running shoes. Create a bar graph for this, right? But you set the interval width, okay? So there's flexibility there. There isn't necessarily one right answer. You pick an interval width that you feel is not too big enough so that you're not left with 1 or 2 bars, and not too small, whereby you're basically graphing data points, okay? So there's flexibility there. Now, I think we discussed this. If you take a look at this particular example, you'll see that the temperatures all lie on whole values of degree C, am I correct? They're all integers?
Yes.
And did we talk about the idea that, and the lowest temperature in there is what? 18 or 19? 18. So, for example, if we went with 4-degree increments, well, regardless, whatever increment size we went with, if we started with 18, and let's say we went up, I mentioned a 3-degree increment. If we said we're going to go with 3-degree increments, the first bar will be from 18 to
21.
And the issue I said with that was...
Like including or not including the 21 and the next one. Yeah.
Right, because 21 is a border temperature, right? It would border 2 bars. So then the question is, well, where do you throw the 21 in bar 1 and bar 2 and so on and so forth? So then what did I recommend? Nicole!
Put it on a legend at the side and say 21 is included in the first line.
Okay, that's one way. And another way, name? Arye.
Make it like just one.
Oh, Nicole, this is pathetic. Just take one for that. Pick the one that you want. This is pathetic. But you know what? It would be nice if after this dessert you continued to participate. Maybe not at the same level, maybe half the level. You pick the best one. Very smart girl. Aside from that one, is that any good, by the way?
Yeah, you just gotta save it. You can't eat it all at once.
It's too heavy duty for me. Too sweet.
Take it time.
See, you like Miss Shevins, you're all okay, Arya, what was it? What did you say?
Make it 21.5, so it includes 21.
Make it 21.5, so the first bar includes 20. You clearly are allocating a 21-degree day to bar 1, right?
21.4, right? You said 21.4, that could mean 21 because rounded.
Yeah, but why would you just notch it? Make your first. I would make my first bar, for example, run from say 17.5, which is lower than the lowest data point, right? up to, let's say, 20.5. And that would force the 21. That would make sure that I don't lose the 18 in the first bar, and that would force the 21 into bar 2, right? So, and technically, by the way, let's say there were some, excuse me, half values or values to the let's say there were values to the nearest tenth in the data. Could you still perform this? Could you still utilize the same logic in a slightly different way?
Yeah.
How would you do that?
Just go halfway between those improvements.
Right. So then you would move to 0.5 or to half values to the nearest hundredth. Correct? So even if there were readings, let's say, to the nearest tenth, like 24.6, 33.8, you could still just say, okay, well, my increments are going to run with 5 values, right, to the nearest hundredth. And that way you'll still never have that issue. Or you could do the legend thing. Nicole, how's it? Oh, you're not even going in yet? Well, you're just going to savor it so that you have a moment by yourself somewhere for you and your dessert? Till you what? Till you have tissue? Oh no, we want to see this.
No, it's a statue of dominance.
Somebody give her a bloody tissue because we want to see you eat this.
You want to record her?
I think we might have to spin the camera when she goes in there. I want to see why dessert, woke you up. I want to know the deals with you and dessert. I want to know this relationship.
It'd be longer than this class.
Anyhow. Alright, so let's use the graphing calculators to do it. Okay? This is useful because it's useful because I suppose, look, in reality, if you were working, you probably wouldn't use a graphing calculator, use a spreadsheet, something like Excel, right? Or Quattro. But the bottom line is that in 2011, you're not going to do stuff like this by hand. You enter the data, and you can do whatever you want with the data, right? Will the graphing calculator save you some time in terms of doing this particular bar graph? I don't know. I think it's debatable. But definitely in terms of matrices, right? It saves you time, agreed? And a lot of other things that you'll see later on in the course. So let's use the graphing calculator and on with it. If you don't want to use a graphing calculator to do this, you want to do it by hand, I have no issue with it. So is this going to be a two-dimensional or one-dimensional graph? Or whatever, just call it out. Is this 2D? Is this considered 2 variable or 1 variable?
2.
It's continued 1. What is your x information? What is your x variable? Nope.
Oh, crap. Well, I stand corrected then.
It's alright. So what's the other option?
Temperature.
Yeah, you don't have to look at our eating to figure that out.
No,
I like that. What's the other one?
He inspires me.
Oh, the eating, okay. Temperature. So then what does the height represent?
Number of times.
Yeah, it's frequency. It's frequency, right? So for a one-dimensional, a bar graph is considered one-dimensional or one variable in that you have your variable along the x-axis and the y is just telling you frequency of the corresponding x value or range of values. So the first thing you probably want to do is, whatever, turn the thing on if you can, which I can. Oh yeah, it works. This is brought to you by OneU. Okay, so we're going to clear, right? So second function plus 7 for reset, 1, 2, we're good, right? Now what you want to do is you want to enter the actual spreadsheet portion of the whole thing, which is what? Where is that? Stat, I believe. And if you pick 1 under the drop down, you go into L1, L2, L3, and so on and so forth. So what we're going to do is under L1, or whatever your first one is labeled, we'll actually enter in all of the temperatures. Another piece of advice that's useful. When you're doing a test and you're using this graphing calculator, whether it be for this test or tests in the future, what I do recommend is actually, as you do problems, I know that this thing caps out at like 6 columns or something, but don't delete the data from question to question. Keep it there. So like if you had to do an XY plot, a two-dimensional plot, use L1 and L2. For the next question, use L3 and so on and so forth. Why is that of value? You can compare them. If you're doing a test, you may want to go and back check you may want to check, see if you screwed up. But if you delete it, then you have to type everything else in again, right? So on tests, I would keep the data there. The only thing is be aware if like you did a question and let's say you plotted a two-dimensional graph y versus x, and then let's say you have to do a 2D graph for y versus x using L3 and L4, just make sure that when you pick your plot and it asks you where's your y data for question 2, you're like my y data is in L4, my x data is in L3, right? You have to always tell it where your data is. Because I think if you don't, it defaults always to L1. Anyhow. So having said that, can we get, Nicole, you're so active today. Can you call out the temperatures for us and we'll all enter them in our calculator.
Day 1, 27.
Yeah, just go from day, you just call it the temperatures. 27.
25. 24.
Yeah.
30. 32.
Whoa, you're a bit fast.
31. 29. 24. 22. 19.
Yeah.
21.
Yeah.
25.
Yeah.
26. 33. 30.
No. Wait.
Hammer time.
No, not hammer time. 30? Yeah.
29.
29.
27. 28. 26. 27. 22. 18. 20.
20 what?
20. 25. 26.
Thank you, Jordan.
29. 32.
32?
Yeah. 31. 28.
Alright, so, you guys have those two? Okay, so now, if we want to create a bar graph, right? We've discussed the offsets, right? With the half value offset. You guys want to go with increments of 4 or 3 or 5 or what? Let's just go with 4. Let's just go with 4. If we go with 4, how far is that going to take us? Okay, let's forget the half value of 17 and a half. We'll back off a half afterwards. Let's say you started at 18, right? Here's the thing. What's your maximum temperature? 33, right? And your minimum temperature is 18, which is a gap of how much? 15. So if you divide 15 by 4, what do you get?
A mess.
Yeah, but what do you get? A little over, a little under?
4.
A little under 4, right? So then we might as well go with, we can go with gaps of 4, right? And then I think our top gap will take us to 33 and a half. We'll see. My math is not that good. So what we'll do is this. First thing we got to do is we got to turn this plot on, right? It's off. By the way, is this easier to see than the thing with the overhead?
Yeah.
This is probably even better, right? Just using the virtual one. This is way better. Okay, so we're going to turn it on. And here's the thing. You want to, for the bar, you want to switch it to bar graph, right? So switch it to bar graph. And then our data, our x-axis, we said was daily temperature, right? Which is in L1, right? So imagine if this was a second question on a test and you were using it in L4. You entered the data in L4. You've got to make sure that you switch that to L4, right? Don't forget that. Don't be like, Mr. Segev, it's your fault. You know, I left it at L1 and then you made it complicated and you made me enter the data and I screwed up and my parents hate. No, I don't want to hear it. Okay, if you enter the data in L4, make sure that you turn that to L4. Okay, we're going to leave that at a frequency of 1, which means that every single data point in L1 is got a frequency value of 1. Now, we're going to go to the window. Question? So what did we, yes ma'am, name?
What did you, Natalie, how
Natalie.
did you get to the plot page?
Oh, second function and the y equals button. And then you pick 1 for, so what, second function, y equals button takes you here, right? And then Natalie, here, watch first, and then do here, here. Then you access that with the number 1, and then you do your thing. Okay? So, is that good? You good? Okay, so for window, what did we say our minimum value is going to be, Sheba?
A minimum?
Yeah.
18.
No?
17.5.
Yeah, 17.5. Okay. Pick a number between 0 and 10. Pick a number between 0 and 10.
4.
Okay, Jordan, you got dessert.
I don't really want
It was 2. Okay, Sheba, you get it. That was
What if we 10, Sheba?
It was 2, by the way.
Why would anyone ever put 10?
All right, so let's do, I don't know, let's go with, so if I do that, if I do 17 and a half to 21 and a half, that's an interval width of 4, right? Right? So, hang on a second. Actually, no. That's not good. 17 and a half is good. What was our highest temperature? 33. So I think 33 and a half works. So we will see. All I'm doing right now is I'm setting the domain. I'm setting the domain. Y minimum. Do we have any negative frequencies here? So we might as well not waste space. So let's make that 0. The maximum. What's the maximum frequency of any particular? What's the temperature you see that occurs most in the list? You don't really have to do it. You can just graph it. You know what? We'll leave it at 10. We'll graph it, and if any of the bars are cut off, we'll just increase the Y max value. Okay, it's faster. Y scale, I'm going to leave it 1. Unless you had like a million data points for a temperature, you might want to change it to 2, right? So that you squash the size of the bars. And the X resolution, this I believe, no, up to X scale. What do we want to change X scale to?
0.5?
I believe, no, I think that's what we wanted to change to 4, right? Because I think the X scale is going to set the bar width, I think. So let's make that a 4. And let's leave the X resolution at 1. And then let's do like this and do like this. Okay, so we're cut off at the top. So what will I do to adjust that?
Make the Y value.
Oh no, don't make it there.
Why not?
Why not? Make it big.
If you make it 4, that's all fine.
Oh, we make it higher. I make it 12. I don't know.
That's a terrible access.
I didn't say there was a good one. Okay. So here's a cool feature about this. Someone in the other class found this feature, which is nice. If you press the trace button, what's cool about this is, check it out. What it does is it starts you off on the first bar, isn't that nice? And it tells you, oh, this is the first bar, which is giving you frequency of daily temperatures between 17.5 and 21.5 degrees Celsius, and the frequency of temperatures between 17.5 and 21.5 is, isn't that nice? So you don't actually even have to read the thing. And then I think if you just hop over on the right side, boom, this one's giving you between 21.5, 25.5, frequency of 7, frequency of 11. Does it make sense that our bar was cut off before? Why was it cut off? Because the Y max was defaulted at 10,
So
right?
basically, so it's saying that there's 11 temperatures that are between 25 and 29.
Correct. There are 11, yes. Or you can think of it as, yes, or 11 days in which there were temperatures between 25.5 and 29.5, both correct. So really, I guess you remember when I said, remember I left the Y max at 10 and then I was like, well, let's just amp it to 12? I guess technically if you're smarter, you could probably hit the trace button first, scroll over to a bar that's chopped off, read the frequency, and if like the frequency is 50, then go to the window and just set it to like 51. You got it? You guys follow what I'm saying? And if you're in a situation, what could you do if let's say this thing was like 50 or 100 and these were all still at the same height? You would end up with, your bar graph would look like this, flat line, huge spike, flat line. You would lose all this information. So what could you do to get that back? You can't. I was going to say you could change the actual scale, right, which would squash the top, but then you're squashing the bottom. You have to go to logs. You'd have to go to a logarithmic scale or something like that. Yeah?
My graph, I think I missed like the part where you like the frequency, like something with frequencies. It's just like a bar graph that's just plotting all the data.
You're talking about right here? Are you talking about this area?
Like,
Okay, you fools, come on, let the poor guy ask his questions. Are you like all hepped up on cheesecake? Was it cheesecake, by the way?
oh yeah.
I love the cheesecake, man. I love it.
Okay, so he's gonna ask her. Okay, so are we good with that? Yes, Antonia.
I just don't see how from the window thing you display a graph.
Okay, so the window thing just sets the parameters. Nicole's gonna show you?
Yeah.
Okay, Nicole's gonna show you. Okay, so let's take a look here, Maya. Where are we at? This last one, this last dessert was apparently a free one, and she said to me that it's really good and that I would like it. So I don't know.
Take it for yourself.
No, I can't.
She said you would like it. Why would you trust her?
Or what if that one of us?
How can she ever love again if you know
It's like the shell, the chocolate
I'll
shell.
go back.
The chocolate
I'll lie to her until I ate it. What?
Oh, it was
The
great.
chocolate shell for the one that you ate, was really good.
That was a good one?
Yeah, like,
It's already gone? Oh, can I taste a piece?
what do you want?
That's just chocolate mousse. That's chocolate mousse.
It was like a chocolate shell around the cup. And then like
Oh, like a cakey?
Like, if we put this video on YouTube, how many hits do you think we get?
0.
It's gonna be on comedy.
When they go fuzz and there's nothing, they're like, we have nothing, let's put this crap on. Alright. So, okay, so we did that. Oh. If you take a look on 95, this is somewhat cheesy though. If you take a look at 95, they're like, you can also use the graphing calculator to create the frequency polygon or the cumulative frequency polygon. But the thing is, to do that, let's see, you can use the trace arrows, we discussed that. Oh, there's a cumulative function option. Oh, that's pretty cool actually. Okay, let's take a look at this. Let's take a look at this here. Stop. You too. Guys. Open up your book.
Look over here. This is my book. He's the
Stole Meyer's book. Okay. Okay, this is kind of interesting. Okay, so let's take a look at the top of 95. You can use the trace instructions, which we used actually to do the frequency count. To determine the tally for each of the intervals, enter the midpoints of the intervals into L2 and the tallies into L3. So, what are they getting at there? Why do they want you to do that? So, I guess, let's go to here. So, like, we went with interval widths of 4, right? Agreed? So, when you plot a bar graph, I think I told you, typically, well, one way you can do it is just mark off the beginning and end of each bar. Another thing you can do is just mark the midpoint as a tick mark along the horizontal axis of a bar. So if the first one runs from 17.5 to 21.5, what's the midpoint there? 23.5? Is that right? Kavish, yes? No? Oh, sorry, I apologize. 19.5?
Yeah.
Okay. So one thing you could do is you could go like 19.5, and then what's the next one going to be at? What is it, 23.5?
Yeah.
And 27.5, yes? And 31.5. I'm just thinking though. 31.5?
Yeah.
Okay. And then you could have used the trace function as we did before, right? To get the total for each of the bars, right? What was the first one, a 4?
Yeah.
What was the next one?
7,
Next one?
11.
Is this all from memory?
Yeah.
You have like a photographic memory?
It's 4 numbers.
What? You saying I'm stupid? Okay, go.
9.
What's the next one?
9.
That's great. Okay. It's 4 numbers. I can't remember anything. So, okay. So then you could go ahead and then you could create a frequency polygon, right? So how would you do that, guys? Window. What's my minimum value going to be? 19.5, right? So I pick something a little less, like maybe, I don't know, 18. What was the maximum value? 30. But the thing is, you want... Oh yeah, we're going with the polygon. That's fine. It was... No, the maximum interval that I entered here. 31 and a half. So I don't know, I'll go with 32. And the scale, I'm going to go with 1 now, because I don't want to create a bar graph. Y min, Y max, what was the maximum frequency? 11? Yeah. And let's go back in here and change this to frequency polygon. I personally like the dots not attached, as I told you, right? So I would pick that. And let's see what we...
Wait, when did you pick the first one?
Say that again?
Yeah.
You know what the other thing I just realized was? You have multiple plots. I didn't have to change plot 1. I could have left plot 1 the way it was, right? And then I could have scrolled over to... I could have picked plot 2 to do all this, right? And that way you could have maintained the original graph that you had, the bar graph.
That's what they tell me to do.
Okay, but I don't read these books over and I just do my thing. Okay?
Just do your thing.
Okay, so anyways. Okay, and then our X data is in L. No, it isn't. Is it is? And where's our Y data? Okay, and then we are going to graph. Okay, and there we have it. Right?
How do you change X to L3?
Yeah, you find L3 And then there's the... Did you guys see their little bit on the cumulative frequency function? They're like, let's say you want to turn it into a cumulative frequency graph. You would go into the... If you wanted to change it to a cumulative frequency graph, you go in here, you go to edit, and then you have Chris's favorite function, which is where?
Cumulative sum.
But where is it? I know you wanted to say it, but where is it?
I'm actually not sure.
Second stat.
Second function, stat. What is it, math or ops? No, it's math ops. Option number 6, but wait a minute. You got to make sure that you're right on top of here, right? I'm going to put it on top of L4. Yes?
Yeah.
Yes. So it's going to give me a cumulative sum for each of the intervals. So we're going to go stat. No, what was it? List, yeah. Ops 6. And then we're going to go from where to where?
L3.
Yeah, good.
I get a dessert.
And that's it. You get a dessert. Oh! You want the dessert? Okay. It's all yours.
You deserve that, man.
Actually, you got to give half of it to one. One, would you want half?
No.
I knew it. I knew it. He needs his soul to be pure so that he can figure out technological problems. The dessert would cloud his whole thing. All right. So, see if this makes sense. See if what I'm about to do makes sense to you. Check it out.
Check it out.
Check it out.
Check it out.
Okay, now the only thing is,
Change the dot stop.
no. If you want to play games and be like annoying, then you're not allowed to play with it.
What?
Okay, I just turned off. If I didn't turn off plot 1, that what you'll end up seeing is both graphs. So I just don't want to cloud the issue. So I turned off plot 1 and I entered one in plot 2. Oh, that's good. That's really good. I like that. Now let's see something. So I want L2 versus L4. So let's change the window. L4 goes from 4 to 31.
Y max 32.
I think that should work. Oh. Okay, so it works, right? So you get a cumulative sum, right? Same kind of story. Let's see. If I press trace, let's see if trace does anything. Oh, yes, it does. So what this is telling me, right, is that my first data point, which corresponds to a midpoint of 19.5 for a bar that runs from 17.5 to 21.5, has a frequency of 4, right? It's the exact same thing as the bar graph, just written as a cumulative frequency. What's interesting is if you flip one over, now it's telling you, what is this telling you?
The cumulative sum.
Yeah,
The cumulative sum of the first one is like
right.
bar,
From 17.5 up to
25.5.
yeah, is a frequency of, okay, so that takes care of that. Okay, then they talk about using a spreadsheet. Relative frequency distribution. Okay, fine. Take a look at example 3 very quickly. You don't really need me to take you through this other than to very quickly go over what it is. What do you think a relative frequency distribution is? Well, read it quickly. Read the example quickly, and then you guys can tell me what it is. So that if you're writing a quiz or a test and I ask you to write me a frequency table, and that, as opposed to a relative frequency table, you'll get that right. Okay.
Are you going to continue with lessons? Should I pause this?
How do I pause this thing?
There's a button by the battery, a button by the light.
A what?
A button. There's a button. There's a button by the light.
Say button view.
I think you did. I see a red button for power. I see off, play, M.
To the left. Yeah,
For M?
That pressable, no. That pressable button directly.
First of all, you said it again. Button.
How do I say button?
Button. Button. I like it. What's the difference between a frequency polygon, or between a frequency table and a relative frequency table? You ate your dessert, you know there's none left, and you're just back to normal. You're like, I am kidding me. Now, come on, Nicole, what happened?
She hasn't eaten it.
Oh, shit. I could take it away.
Oh.
Did you read it?
Guzzle that.
Now you're reading it because I'm telling you to read it because you got your dessert because you don't care anymore. Before, you would have read it like an hour ago. Okay, Joanna, what's the difference?
Isn't it like relative frequency only has like a part of the frequency? That
Okay, can you just be, it's the easy, I want the exact answer so we can move on.
I just said
Shows
it.
as a
Like,
fraction.
yeah, there you go. Like a part, a fraction, same thing.
Okay, fine. So for relative frequency, you're looking at a fraction or a percentage, and as a double check, for relative frequency, if you add up all of the relative frequencies for each of the components, what should your sum be at the end? 100% or 1, right?
I still don't get it. I don't understand what you said.
Okay, so for example, for this thing, let's go back to, okay, we'll use the first data point, because the first data point for cumulative frequency graph will be the same as for a cumulative frequency polygon will be the same as for a frequency polygon, right? They should be the same. So what is this telling me? This is telling me, not this one. This one is telling me that for the interval of 17.5 to 21.5, there were 4 days at that temperature. There were 4 temperatures within that range. Agreed? If you want to turn that into a relative frequency, it wouldn't be 4. It would be 4 divided by how many days were there in July? I never remember. 31. So this wouldn't be a 4. It would be 4 over 31. You would take each and every one of the y values, which are the frequencies, and divide them by 31, which takes your actual frequency, turns it into a relative frequency. It's relative to the total, right? So it basically is turning it into a percentage or a fraction, that's all. Okay? So if I on a quiz asked you, build me a table that has frequency as well as relative frequency, you could do your frequencies, let's say, along a column, and then your next column would be taking each and every one of those values, previous values, and dividing them by the total number of data points, right? And then you could check your tally, yeah.
So you'd only give a percent for relative frequency?
You can give it to me as a decimal as well. Same thing, right?
And do we have
Or
to,
you can give it to me as a fraction, as an integer fraction, if you want.
do we have to graph it?
Graph
relative frequency?
Yeah, you might have to, for sure.
But then do you graph it as like a pie graph or not?
Why couldn't you graph it the exact same way? The only difference is your if you did it as a bar graph or a graph like this, what is going to be the max? What's your what could your y max never exceed? 100% or 1. But it's the same thing. And actually, relative frequency to me is much more relevant because what we're going to be dealing with later on in the course, which is actually interesting, we might have to edit that, which is actually interesting, is probability, discrete probability. And for discrete probability, you're always talking about percentages. When we get into continuous probability, you're actually talking about the area underneath a curve, which is another story. But when you're talking about discrete probability, you care about percentage. You know, what is the probability that if I roll a die, I can roll 6? Well, it's a 1 out of 6 possibility, right? And that's relative frequency, isn't it? Or percentage, right? So that has the most relevance to me and to the course. Okay, anything else? What else do they do in here so we can get through this chapter? Okay, so relative frequency. They talk about pie charts. Pie charts are another way of representing data. What's the story with the pie chart? How does the pie chart work? Very quickly, somebody? Lior had his hand up first, yes?
It's basically a version of a relative frequency polygon or graph, except you just use an angle to represent the percentage, so the area also represents.
Nice. So I didn't think about it. I was thinking about the area. So the area is going to be proportional to either the frequency or relative frequency, right? So for example, if you had half of the day, if half of the, sorry, it can't be half. Let's say there were 32 days in July, right? And 16 of those days were above a certain temperature, you would have a pie graph, which would be split in half, right? Half the area would be representative of 1. So the area as a proportion of the entire circle is reflective of the proportion of the data for a particular bar or interval. Capiche? That's pretty straightforward, right? Okay, I think that's it for this chapter. Do I want to start with the next one? No, I think we probably just want to
Wait, speaking of the quiz, what are we
No, that's not it for chapter 2. Next is you mean for the test, or what do you mean? No, I meant for 2.1. I was just wondering if we want to jump to 2. I'll assign some homework, and let me assign some homework, and then tomorrow we'll do indices, which are whatever, and then 2.3. Yeah, let me turn this thing off.
What are we going to do about tomorrow?
Tomorrow, let's talk about that right now. Okay, if I want to do a turn off as opposed to a pause.
You gotta pause it.
You should be watching this. Yeah.
You gotta pause it.
Gotta pause it. Do you want to try so that you know how to do it?
Sure.
Okay, I gotta pause it. I push this button to pause it. Yeah.